Hello everyone, welcome to IGCSE with Optimus. Subscribe to our channel and hit the bell icon to never miss an update on our IGCSE content.
Hello students, so today we are solving paper 42 from May-June series 2024 for subject physics. You can see on screen, question number 1 says that a load is suspended from a thread. The vertical force on the thread due to the load is 0.75 Newton. Calculate the mass of the load. We know the formula for weight, that is mass multiplied by gravity. So mass will be W by G, that is 0.75 divided by 9.8, and the answer for this is 0.077 kg. Question B says, figure 1.1 shows the load suspended from the thread. A wire is attached to the load at point X and pulled horizontally to the right. So understand that at point X, there is a wire connected and it is pulling the load towards right side. The tension in the wire, in the horizontal wire, is 1.2 Newton. So on the right hand side, the wire is applying force or experiencing force of 1.2 Newton. We know that the weight of the load which is acting in downward direction, it is of value 0.75 Newton. By drawing a scale diagram or by calculation, determine the magnitude of the resultant force at X due to the load and due to the tension in the wire, and we are supposed to find the direction of the resultant relative to the vertical direction. So since they have given us option of by drawing scale diagram or by calculation, we can choose the shorter method, that is by calculation. We know that we have one force acting towards right side, that is 1.2 Newton, and we are having one force acting in downward direction, that is the weight of the block, which is 0.75 Newton. The resultant can be given as the third side of the triangle like this, and to find this side or the resultant, we can use Pythagoras theorem. So R will be equal to under root 0.75 square plus 1.2 square. If we do this on calci, we get 1.42 Newton. Now 1.42 Newton is going to be the value for resultant force. The other thing that they are asking us to find out is the direction of the resultant relative to the vertical. So we are supposed to find this angle. The vertical force is 0.75 Newton. So this angle will be our angle that we are supposed to find. We can use trigonometric ratio tan theta, which is opposite upon hypotenuse, that is, opposite upon adjacent, that is 1.2 divided by 0.75. So theta will be tan inverse of 1.2 divided by 0.75. The angle is 58 degrees. So our resultant is 1.42 Newton and the angle to the vertical is 58 degrees. Question C says that forces may produce changes in the size and the shape of the object. State two other changes that force may produce. So we know that force can change the motion of the object, force can accelerate or decelerate the object, and force can also change the direction of the moving object. So here we can write the force can change velocity of the object, or you can write acceleration of the object, or force can also change the direction of the moving object. We will go to the second question now. Question 2, first part says define acceleration. We can write acceleration, definition of acceleration as rate of change of velocity. Question B says a train has total mass of 520,000 kg. The train accelerates at 1.1 meter per second square. Calculate the time taken for the train to increase its speed from 15 meter per second to 28 meter per second. We know the formula for acceleration. It is v minus u upon t. So t will be equal to v minus u upon acceleration, that is 28 minus 15 upon 1.1. The answer for acceleration is 11.8. We can write it as 12 second. Answer for time, sorry. Calculate the force required to produce the acceleration of 1.1 meter per second square for this train. So value for force can be given as, calculated as mass into acceleration. Mass of the train is 520,000 and the acceleration is 1.1 meter per second square. So 520,000 multiplied by 1.1, your answer will be 5.7 into 10 raised to 5 Newton. Next question. The train uses electric motors. Explain why the force on the train due to the motor is greater than the value calculated in 2. So understand that the acceleration value that we are given with 1.1 is the value due to the net force acting on the object. Net force is calculated as forward force minus the backward forces like friction or the air resistance. For train to accelerate forward, the forward force must be greater than the backward force, and that is why here we have to write that the forward force is greater as train experiences friction or air resistance. So for any object to accelerate forward, its forward force must be greater than the resistive forces acting on the object in backward direction. Question number 3, it says that a student drops a heavy ball from a vertical height of 1.8 meter above the ground. The ball then falls to the ground. It does not bounce after hitting the ground. Describe the transfers of energy of the ball between the stores from when the ball begins to fall to when it reaches the ground. So understand the movement of the ball. The ball is held at height 1.8 meter. At that point, the ball is going to have gravitational potential energy. When the ball starts moving downward, the same gravitational potential energy will decrease and it will be converted into kinetic energy of the object. Then when the object is colliding with the ground, it hits the ground, the same kinetic energy will be converted into thermal energy of the object. So we can say that the gravitational potential energy decreases as ball falls, due to which the kinetic energy of ball increases. As ball moves downward, kinetic energy is converted to heat or thermal energy. Why so? Because when the ball is moving downward, it is going to experience air resistance, and the kinetic energy, some work needs to be done against air resistance. So kinetic energy is going to be eventually converted into thermal energy. The next question says, calculate the maximum speed of the ball, ignore the air resistance. So we know that as the ball is falling, we will assume that its gravitational potential energy is converted into kinetic energy. So we can say that GP lost is equal to Ke gained by the ball. Formula for GP lost will be mgh and Ke gained is mv square. So mass from both sides will be cancelled and we will get formula for V square, that is equal to 2gh, and so V will be in under root of 2 into g into the height, that is 1.8 meter. The answer is 5.94. So we can write 5.94 meter per second. Question number 4. State two ways that evaporation differs from boiling. So we know that evaporation happens on the surface of the liquid, whereas boiling happens throughout the liquid. That can be our first point of difference. Second, evaporation occurs at any temperature or range of temperatures, whereas boiling for every liquid happens at a fixed value of temperature. We call it as boiling point. So we can say evaporation occurs only at the surface and evaporation occurs at range of temperatures, whereas boiling occurs at fixed temperatures. Question B, it says figure 4.1 shows part of container used to store a mixture of liquid and gaseous oxygen. You can see the container, the walls of the container are steel walls. There is a vacuum between the two walls of container. The question says the temperature of the liquid oxygen is minus 160 degrees Celsius. Determine the temperature of the liquid oxygen in Kelvin. How do we convert any degree Celsius value into Kelvin? We add 273 in that value. So minus 160 plus 273 will give us number 113. So the temperature in Kelvin is 113. The container is made up of steel and there is a vacuum between the inner and outer walls. The outer wall of the container is at room temperature. State two methods of thermal energy transfer that a vacuum prevents. How many methods are there for the thermal energy transfer? There are three methods for thermal energy transfer: conduction, convection and radiation. Out of which conduction and convection can be stopped by vacuum, but radiation cannot be stopped. Radiation can take place even through vacuum. So here the answer would be conduction and convection. So vacuum is stopping these two processes from taking place, conduction and convection. Question C, describe in terms of particles how a gas exerts pressure on the walls of the container. We know the formula for pressure, it is force per unit area, and we also know the formula for force, it is change in momentum of the particles upon time. So we have to write the answer in terms of change in motion of the gaseous particles and how this motion causes force which leads to pressure on the walls of container. We can write here the gas particles collide frequently with the walls of container. Because of this, their momentum changes. Change in momentum applies force on the walls, and this force per unit area causes pressure. So the important pointers in the answer would be how the gaseous particles experience change in momentum and how the change in momentum leads to force which leads to pressure. We will go to question number 5. Question says that figure 5.1 shows a ray of yellow light incident on glass prism ABC. Explain why the ray does not change direction when it enters the prism at face AB. Now first we need to understand that when the light changes its direction, when it is changing the medium. Whenever light changes the direction, whenever light changes the medium, if it has any value of angle of incidence, then we can see some value for angle of refraction. Now what is angle of incidence? It is the angle between incident ray and the normal drawn to that boundary. If you see for this ray, if we consider the normal drawn, then the line that is followed by yellow light is the same line that can be considered as normal. So the light is actually falling on the path of normal. If light is coming on the path of normal, the angle of incidence is going to be 0. And so we will not see any change in the direction of the light. We can write light follows the path of normal on the boundary. Hence, the angle of incidence is 0. Question B says the critical angle for the glass is 42 degrees. Calculate the refractive index of the glass. Show your working. What is the formula that links refractive index with the angle of incidence, or you can say critical angle? The formula is n equals to 1 upon sine c. So if I have to find out n, I can simply substitute the value of critical angle. It is 1 upon sine 42. The answer that we get is 1.49. We can write it as 1.5. Question 2 says that on figure 5.1, continue the path of the light through the prism and after it leaves the prism. Now what we need to do over here is first we have to draw a normal to the boundary BC where the light is touching the BC, something like this. Okay. Then what we will do, we have to measure the angle of incidence over here. And if I measure this angle of incidence, it is going to be greater than the critical angle which is given to us, and the value for that is 42. So if this angle I is beyond 42, I know that the light here is going to be internally reflected. So whatever this value of I is, I am going to measure the same value of refraction over here, and I'll be drawing the line which is expected to go something like this. Note that whatever the value of I is, the same value of R you are supposed to draw. So here, if the light is reaching the boundary AC, you can see now also it is reaching exactly on the path of normal. If it reaches on the path of normal, again out of this, it is going to go straight without any deviation. So we can consider the path like this outside the prism. Had it been any other value for angle of incidence on AC, then the light would have gone away from the normal, because light, when it goes from denser medium to rarer medium, it goes away from its original path. Question C says internet data can be transferred using infrared waves in optical fiber. What are optical fibers? These are the thin wires which pass information converted in the form of light signals. So whatever information data we have, we convert that into light pulses, light signals, and we pass it through the optical fiber. State 2 advantages of using optical fiber to transmit the data. Since the data is converted into light, we know that light is the fastest mode of transfer of energy. So the data transmission is going to be at faster rate. We can write faster transmission of data. And second would be, since optical fiber uses principle of total internal reflection, here the data signals will be you can say saved, and the data loss can be avoided. So we can write less loss of data when they are passing through the optical fiber. Question number 6, it says a sound wave travels through air. Figure 6.1 shows pressure time graph for the air at one place. Note that the graph that they have given us is the pressure time graph. So they are showing us how the pressure is changing in that region as the time is progressing. You can see the wave indicates at some point the pressure is higher, whereas at some point the pressure is 0. They're asking us on figure 6.1, label 1 point C to indicate compression. Now what we know about compression? Compression is a region of high pressure. And they're asking us to label 1 point R to indicate rarefaction. Now what is rarefaction? It is the region of low pressure. So compression can be pointed or labeled where the pressure is higher, and rarefaction can be labeled where the pressure is lower. Next, they are asking, explain why this graph cannot be used to find the wavelength of the sound wave. Now to find out the wavelength, we need to know the displacement of the particle, because wavelength is the distance between the two consecutive compressions or rarefactions. For that, we need to know the movement of the particles from their mean position. The graph that we are given with is not showing the displacement of the particles, and that is why we cannot find the displacement, we cannot find the wavelength of the wave looking at this graph. So we can write the reason for this is graph does not show the displacement of the particles. Question 3. The sound becomes louder and of lower pitch. State what happens to the amplitude of the sound and the frequency of the sound. We will first try to understand the relationships between the quantities, and then we will write the answer. The first quantity they have asked is loudness. Loudness is directly proportional to the amplitude of the wave. Meaning, if the amplitude increases, the wave sound becomes louder. If the amplitude decreases, sound becomes less louder. So, for the amplitude, we can say if the sound is becoming louder, the amplitude is increasing. The second they are asking is about pitch. Pitch is inversely proportional, pitch is directly proportional to the frequency. Note that pitch is inversely proportional to the wavelength of the wave. So here they are asking about frequency. If the pitch is lower, the frequency will also be decreased. So here we will write the frequency decreases. Next part, a sound of frequency 13 kilohertz is transmitted through the water. The speed of the sound is 1500 meter per second. Calculate the wavelength of this sound in the water. We know the formula that links velocity, frequency and wavelength together, that is V equals to F lambda. So lambda will be equal to V upon F, that is 1500 divided by 13 kilohertz. Note that it is kilo, so we have to convert that into SI unit, that's hertz. So it is 13,000. 1500 upon 13,000, the answer is 0.12. So the wavelength will be 0.12 meter. State the approximate speed of sound in air. So the speed of sound in air is between 330 to 350 meter per second. Any number between these two values are valid for this answer. So we can write 330 meter per second. We will go to the question 7 right now. Question 7a says that figure 7.1 shows 3 bars of steel A, B and C. A student is given with 3 pieces of steel. 2 of the pieces are magnetized and 1 piece is unmagnetized. Describe and explain how the student determines which piece is unmagnetized using only the 3 pieces of steel. Now here we need to know one property of the magnets. We say that repulsion is a sure test of magnetism. So if 2 objects are magnets, then at least by one end of them they will be repelling each other, because 2 poles, similar poles of magnets, when they are in front of each other, they will be repelling each other. For example, suppose we are keeping A like this, we bring B's left end in front of A and the right end is over here. Let's say here A attracts B. But assuming B is a magnet, if I switch the polarities and we keep the right side on the left right now and the left side on the right, here it is going to repel. Why? Because after we turn the poles, two same poles will be in front of each other and then they are going to repel. So repulsion is a sure test of magnetism. How we will help the student to find out which piece is magnet and which piece is unmagnetized? We will write the standard answer for this. We will say that student can keep bar A fixed and he can bring bar B and C near one end of A. If any of B or C is unmagnetized, then it will be attracted to A from both of its ends. However, the magnetized bar will only be attracted to A from one end, but it will be repelled by A from the other end. So understand, we are keeping A fixed. We are first bringing B closer to it. Let's say B's left side or right side is getting attracted to A, meaning B is unmagnetized. But if let's say B is getting attracted from one point towards A, but when I twist and switch the polarities and the B is getting repelled by the A, meaning B has to be B must have the magnetic properties, and so it is getting repelled from one end of the A. Question B, figure 7.2 shows a circuit diagram of a step-down transformer. Now, what is the property of step-down transformer? In step-down transformer, primary coils are greater in number and the secondary coils are less in number. Here, they are asking the mains voltage supplied to the transformer is 240 volt. The output power of the transformer is 45 watt. The transformer is 100% efficient. Calculate the input current to the transformer. Now, when the transformer is 100% efficient, we use a assumption, you can say, that is total power input is equal to total power output. Then only the transformer can be assumed to be 100% efficient. So, we can say power input is equal to power output. Now, what is power input? It is voltage input into current input, and the power output would be voltage output multiplied by current output. But here we already have the value for power output, which is 45. The voltage is 240. We are supposed to find current. Input voltage is 240. We are supposed to find current, and the output is 45. So I will be 45 upon 240. The answer is 0.187. We can write 0.19 ampere. Next question, they are asking, draw a label diagram of a step down transformer. On the labels, state suitable material for each of the components. So a standard diagram for the transformer should include an iron core. We have to include primary coils and the secondary coils in the diagram. So let us say this is an iron core. On the left hand side, we will show primary coils. Since it is a step down transformer, the primary coils must be greater in number than the secondary coils. So here, when we are showing secondary coils, we have to show them significantly lesser in number than the primary coils. Like this. So we have named one as iron core. We have to name the coils as well, and suitable, we have to suggest the suitable material for them. So the suitable material for coils would be copper. Question number 8. Figure 8.1 shows a circuit. The circuit is designed to switch on a night light when the surrounding is dark. See the circuit first. In circuit, we are seeing one component over here. This component is LDR, light dependent resistor. We'll quickly try to understand the function of LDR. So it is a light dependent resistor. Whenever there is a high intensity of light falling on LDR, its resistance is lower or decreases. But if there is dark surrounding, then the resistance of LDR increases. Then we have one resistor over here, and parallel to LDR, we are having one component, that is LED connected. On figure 8.1, draw a circuit symbol for the voltmeter used to measure the potential difference across light dependent resistor. We know that whenever we have to measure the potential difference, we have to connect voltmeter parallel to that component. Okay, so we have to measure the potential difference across LDR. So we are going to connect a voltmeter parallel to LDR like this. Okay. Next question, the surrounding changes from light to dark. So now the light intensity has decreased, so the resistance of LDR is going to increase. State the effect of this change on the resistance of LDR. As we said, the resistance of LDR is going to increase. State and explain the effect of this change on the potential difference across the light emitting diode LED. Now few things to understand here, that whenever the resistance increases, the voltage or potential difference across that component increases. Because what is potential difference? It is the energy supplied to move the charge through that component. If the resistance applied by component is greater, then the energy needed to move the charge through that component will also be greater. So voltage and resistance are directly proportional. Here, if resistance of LDR increases, then the voltage here will increase. Since LDR and LED are parallel to each other, whatever voltage value we will see here is the same value that we will be seeing across LED. So if voltage across LDR increases, the voltage across LED will also increase. So we will write potential difference across LED will increase, and the reason for this will be LED and LDR are parallel to each other. If resistance of LDR increases, PD across LDR and LED will also increase. Next question, question B. Figure 8.2 shows another circuit. Lamps A and B are identical filament lamps. Now when they say identical filament, what we need to understand from this point is that they have same resistance. Now if the resistance is same, then the current is going to be equally splitting between these two components. The current supplied by power supply is 0.50 ampere. So what we understand is the current here is going to be 0.50 ampere, and this current is then going to split from here. A part of it is going to go here and another part of it is going to go here. Since the lamps are identical, their resistance are equal, so the split of current is also going to be equal, that is in the ratio 1:1. Here the current will be 0.25 ampere and here the current will be 0.25 ampere. Using this, we can calculate the resistance of lamp A. Resistance is equal to voltage upon current. Since both the lamps are parallel to each other, the voltage across both of them is going to be 240. The voltage will be 240. Current across each lamp, we can show it like this, is 0.5 divided by 2. So if we do this on calci, we get the answer for resistance as 960. So the resistance of each lamp is 960 ohms. We will go to question number 9. Question says, radioactive isotopes that emit ionizing radiations are used in hospitals. State and explain 2 safety precautions necessary for the use of these isotopes in the medical procedures. So the standard precautions that we have to follow whenever we are handling radioactive isotopes would be to reduce the exposure time. We have to ensure that these radioactive isotopes are kept in strong shields which are made up of steel or concrete. We have to reduce the handling. You can say that we should avoid the direct contact with these radioactive isotopes, and also we can keep these radioisotopes away from the regular area. So the first point or first safety procedure we can write is reduce exposure time. Okay, and why we should do that? Because longer exposure will make greater absorption of radiations. So if you are in front of radiations for a long time, your body is going to absorb more and more radiations. The second would be use concrete walls or lead walls. Why? Because concrete or lead walls reduce the penetration of radiations. Question 2 says, give 2 reasons why alpha emitters are not used as radioactive tracers inside the body. So we know one property of alpha radiations, that they are highly ionizing. So if they go inside the body, they are going to cause damage to our cells. And secondly, they are also not very penetrating. So if they are not penetrating, they will not be able to come out of the body, and we will not be able to trace them outside the body. So the first point would be they are highly ionizing, which is a problem. And second, they are less penetrating, so cannot be detected outside patient's body. Question B, sodium 24 is an isotope of sodium that has proton number 11 and the nucleon number 24. Sodium 24 decays by beta particle to form an isotope of magnesium. Use nuclide notation to write down the nuclide equation for this decay. We can write sodium, its proton number is 11 and its mass number is 24. It is going to decay by beta emission and forming magnesium. So we can write like this. Beta has charge -1 and mass 0. Whenever any radioactive sample releases beta, its atomic number increases by 1. So sodium has proton number 11, its proton number will increase by 1 and it will become 12, and there is no change in mass, so it remains 24, and that is our nuclide notation. Question 10a, solar system includes sun and the planets. State 2 other types of natural objects that orbits the sun. The first we can write is asteroids, okay, and second we can write some dwarf planets. So since they have said here about planets, we are not going to directly write planets, we will write dwarf planets which are not considered to be the part of our solar system, for example Pluto. Next, they are asking, state the shape of orbits of the planets. So the orbits are considered to be circular for the calculations of orbital speed, etc. But the actual shape of orbits is elliptical. So here we are going to write the shape of orbit for the planets is elliptical. Question C, figure 10.1 shows the orbit of an object around the sun. At point A, the object is closest to the sun. At point B, the object is furthest away from the sun. State and explain the energy transfer as the object travels from A to point B. Now understand, when the planet is closer to the sun, it experiences greater gravitational pull from the sun, which results in greater kinetic energy. So when the planet is at point A, it is going to have higher kinetic energy, but when it goes away from the sun, the kinetic energy goes on decreasing. Why? Because the gravitational pull will decrease. So here kinetic energy is going to be lesser, but since the energy is always conserved, the gravitational potential energy of the planet is going to be greater at point B. So we can write from point A to B, kinetic energy of the planet is converted to gravitational potential energy. In explanation, we can write Ke decreases as gravitational pull decreases, but energy is always conserved. So since the energy is always conserved, whatever decrease in kinetic energy will result in increase in gravitational potential energy of the planet. Question D, Jupiter is 7.8 into 10 raised to 11 meter from the sun. The speed of the light in vacuum is 3 into 10 raised to 8 meter per second. Calculate the time for the light from the sun to reach Jupiter. We can simply calculate time by using distance upon speed formula. Distance is 7.8 into 10 raised to 11 divided by speed 3 into 10 raised to 8. The answer is 2600. So we will write 2600 seconds. Question number 11. First, name the galaxy that contains sun. We know that the galaxy name in which our sun is present is Milky Way galaxy. So we will write the answer Milky Way galaxy. Light observed from the distant galaxies is redshifted. State the theory of the universe that this observation supports. So the theory called as Big Bang theory supports this suggestion of redshift. In brief, what is Big Bang theory? It suggests that all the universe that we are seeing right now, it was earlier or at the start, it was a clump of mass, and eventually all the particles started going away from each other, which states that the universe is continuously expanding. Cosmic microwave background radiation is observed at all points in the space. State when this radiation was produced. We can write just after the start of universe, or you can say start of universe as in the birth of the universe. Explain why this radiation is now in the microwave region of the electromagnetic spectrum. Quickly, if we talk about electromagnetic spectrum, then at the top of the electromagnetic spectrum we have microwaves, and towards the bottom of the electromagnetic spectrum we have gamma rays. Now what is the property of microwaves? They have longer wavelengths like this, whereas for gamma rays the radiations are of shorter wavelength and greater frequency. They are saying the radiations are now in microwave region means their wavelength is increasing. Okay, now why the radiations are found in microwave region? It's because the radiations are redshifted. What is redshifted? It means they have as they move away, the wavelength coming from them, it increases and it moves towards the red part of the visible spectrum. Now eventually from the visible spectrum it is going to get into infrared, and then from there it is going to get into microwave region. So the radiations are redshifted. And why is that so? Because the universe is continuously expanding, and as it is expanding, the particles are going away, the planets, the galaxies are going away from each other, and so the light coming from them, it happens to be or can be seen as redshifted. Thank you.